Okay, so Radhe Radhe, I think I'm live. So just confirm me if I'm live or not, okay? Because I don't know whether I'm live right or not right now. Guys, can you confirm me whether I'm live? Hello, hello. Okay, okay, okay. Perfect. Hello. So just wait a minute. I'll just fix my camera, okay? Just fix my camera. Window projector. Okay. This is the vertical version of my camera actually. So this is perfect right now. My camera is perfectly set. So how many questions did you guys do in today's LeetCode challenge? Huh? How many questions did you guys do? Can you check my code? Yeah, I was just going through your, like, I just saw your code. I just saw your code, but I haven't like gone through it completely. Okay, let's do one thing. Let's first start with the whole video. Okay, let's just start with the whole video. Then I'll just go on with the fourth one, and you can check it over there. Okay, you did two questions. Even I did two questions only, like because I was like not that serious while I was coding today. But yeah, the fourth one was easy. I did the fourth one, I guess. No, I did the third one, and the fourth one I did till 576 test cases because I was not being able to hash it perfectly. Okay, so let's get with the description of the first question. Okay, the first question: minimum elements after replacement with digit sum. You're given an integer array nums. You replace each element. True and wrong answer on fourth 5 times. My wrong answer on fourth is, I think it's more than you. How can I see it though? I got, okay. I also got 5 times only. Okay, so it's okay. Equalized. Fourth one you did till 770 test case. Which algorithm were you using, by the way, Keaton? I think you were using Z algorithm, no? Z or KMP or something like that. Okay, so you replace each element in nums with the sum of its digits. Return the minimum element in nums. Okay, after all the replacements. So basically, what this was a very simple thing. You basically needed to do this. That is, go throughout the whole array and find like the sum of digits for every number. You know how to do it. While n greater than 0, d plus is equal to n mod 10 and n by is equal to 10, right? This is a very easy thing. I won't discuss it much. Okay, but since like my video is being seen by like from beginners to advanced, so I'll prefer like explain it throughout only. So basically this was the first problem. Okay, the first problem was quite easy. You have written the minimum. So based on this whole values, based on this value for every element of ARR, you have to return the minimum one. So basically that's what I have done. I've taken, I don't know what algorithm I used. I read the question, the solution which I sent you came into my mind. Okay, so after like explaining this, I'll just go through your code. Okay, so while nums of I is greater than 0, d plus is equal to nums I mod 10 and nums I by equal to 10, and you have to find the minimum of that d. Okay, and then you print the answer. So is this clear with you guys? Is the first question clear? I am assuming that it's clear. Okay, but if it's clear, then just write in the live chat B. Okay, so that I'll go to the next question. Meanwhile, I'll just go through Keaton's code. Crystal clear. B, 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 B. This seems to be a nice logic though, Keaton, but I'll just go through the whole thing. Okay, just wait. So the second question, maximize the total height of unique towers. You're given an array, maximum height, the constants were 10 to the 5, I use n squared. Yeah, oh, actually you use 10 to the power like n squared. Oh, yeah, yeah, then it will be a error only, then it will be error. I mean, that will be TLE only. I didn't go through your code completely. So you're given an array, maximum height, where maximum height of I denotes the maximum height of ith tower that can be assigned to it. Okay. Your task is to assign a height. I think I'll just shift this thing a little bit over here so that it's better for you to see. The height of the ith tower is a positive integer and does not exceed maximum height. No two towers have the same height. Return the maximum possible total sum of total heights, tower heights. If it's not possible, then return height. Okay. So this question I'll explain with an example. Okay. If I'm taking this example, so first throughout the question, I'll just tell you what the question tells us. So for every tower, the height of the tower has to be this number or lesser than that, lesser than equal to that. Okay. So that means this tower will be of height 3 or lesser than that. This will be of height 4 or lesser than that. And this will be again of height 3 or lesser than that. And this will be of height 2 or lesser than that. Now see one thing. 4 is standing alone, so it's not a big issue for us. But there are two 3s. So one of them will be 3 and the other will be 2. But the moment the other one becomes 2, now the other one is also 2, so it has to become 1. Okay. So that's what basically the question is all about. Okay. So you have to make all of them unique. All of the tower heights unique. Okay. Now you have to find out what is the most optimal approach to do this. Okay. Now if you look at the question, if you look at the test case, the maximum height of all the towers is equal to 4. That is the maximum of the whole array. Why so? Because that is the maximum height that I can attain, right? Now let's say if there were more than one force, okay, if there were more than one force, so what would have the height been? This height will be 4, but the next height can't be 4. Exactly. But the next height can't be 4, so it will be 3, and the next height it can't be 3 also, so it will be 2, right? Now let's say there was a 3 over here. Now this will be 1, and let's say there is a 2 over here, so this will be 0. Now remember one thing, any number, like whatever it is in such a manner that it can't be a 0 or a negative number. Okay, it was given that is no towers have the same height and it is of a positive integer, right? It was given that it is a positive integer, so this 0, this won't be calculated, I mean this won't be considered only if there is a 0 over here. Now if you look at this, there is a pattern of 0 1 2 3 4. So basically you can say one thing from here, that you are just taking all the numbers from the maximum element till the end and you make -1 throughout the whole thing, right? So that is one thing that may come to your mind, because the whole array is now sorted. Okay, this happens only if the array is sorted only, because if the array is sorted, then only the previous element is lesser than that. But what if the array was not sorted? So let's say there would have been a 5 over here. In that case, this could have been written as 5, and this will be written as 2, and this will be written as 1, and it will be a valid thing, right? But whenever, so in order to make it more valid, so we have to first sort it down. Okay, so let's say you have got a few elements. Okay, a, b, c, d. Actually got a doubt initially. I was using an approach of sorting the array and descending and maintaining a set, and if an element found in the set, then decrease it and add. Okay, e, f, g. For now, this 7 numbers are more than enough for us just to look into the whole thing. Okay, now if you look into this, just observe this minutely. G is the maximum among all of them, so this value can be G, and the previous value, it will be G minus 1, because it can't be greater than G, because this F is lesser than G, right? If it is lesser than equal to G, so it can't be greater than G, because the maximum height of a tower is that element only. Okay, so it has to be G minus 1. But what if F is lesser than G minus 1? So that can also not be G minus 1, right? So in that case, it will be F. So what will be the corresponding value for that specific tower? It will be the minimum among them. That is minimum among F comma G minus 1. Kind of, yes. Kind of, you're right. Okay. So it will be better for you to, like, you are actually right, because if you notice whatever I was explaining till now, so this is what you will come up to, and this is also the answer also. Just a slight modifications maybe. So one thing you are very much clear about, that the element is either the previous element minus 1 or that element only, whichever is going to give me the minimum value. I am going to take that. So based on this, what you can do, you can go throughout the whole array and find out the maximum sum. Is this clear with you guys? If this is clear with you guys, then only I'll go to the code. If this is clear with you guys, just write in the comment. Just write in the live chat. Clear, 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 like that. Okay. Anyways, people who are new to my channel, it will be a mild request from my side. Please do subscribe my channel and like this video. Okay, it will be helpful for me and it will be motivational for me to make more videos also. Okay, now see, the code is very simple. You don't need to focus much on that. I am sorting the whole array out, and then I am taking the answer initially as AR of n minus 1. Why? Because I know one thing, that the last element will always be there in the answer, right? So I can directly take the answer. Okay, I'm directly taking the answer, and then I'm taking a value of k, which is AR of n minus 1 minus 1. That is this G minus 1. Okay, that is this G minus 1. Now for every situation, I'm going to check whichever is minimum, the k or AR of I. Whichever is minimum, I have to take it. But remember one thing, that the value, it can't be lesser than equal to 0. Why? It was always given in the question that it is a positive integer. So if it is lesser than equal to 0, in that case we can say that is a minus 1. That is, the case is not valid. So we can directly return minus 1. Otherwise, answer plus equal to k. And for every step, you make k minus minus. Okay, that is not clear. Okay, let me take a bigger example so that it will be clear for you. Let's say you have this. Okay, 2, 1, 3, 3, let's say 5 over here, and a 4 over here. Okay, now if I sort it out, so it becomes 1, 2, 3, 3, 4, 5. Now since 5 is the largest number, So all the remaining towers will be of height lesser than equal to 5, right? So it is better that I give 5 to this element only. I make the height of this tower 5. Now since the height of this tower is 5 and the height of the previous tower has to be lesser than 5 because there is no element that is greater than 5 at this moment. So it will be 5 minus 1, that is 4, right? And if you look at it, 4 is a valid thing because 4 is the maximum height that I can have over here and it is 4. Similarly over here it will be a 3, right? Now similarly over here you may say that it will be a 2. Similarly over here it will be a 1. And similarly over here it will be a 0. But the moment you reach a 0, you can say that it is not possible because the height of the towers has to be greater than 0 because it has to be a positive number. But now what if there was a little bit of confusion over here? Okay, let's say this element was 2 and this element was 4. Okay, so I'll just do what? I'll just erase it. Okay, so this element is 2 and this element is 4. Okay, now in that case this element will be 3, right? 3 is possible and this element will be 2, right? Now I'm going to like put one put another thing in it. Okay, that is, let's say everything is okay but there was a 1 over here. In that case this 3 would have become 2, right? But this 1 is the maximum height. What if it is not consecutive? Do you mean consecutive? Clear, right? So if it is 1, then in that case you have to rewrite it as 1. Okay, it will be better like if you look at this dp. Okay, if you look at it, what am I saying? If you look at it like a sense of dp, it is like dp of I is equal to minimum of ARR of I and dp of I plus 1 minus 1, right? Because it can't be dp of I plus 1 more than that. It can't be that. Okay, because the previous element was the maximum element and the present element is lesser than that. So in that case, that is the only thing that you have to worry much about. Okay, so since it is clear, Kundan, is it clear for you? The code is this simple. Okay, the code is this simple. Actually, if it is not clear, I think if you like sit on watch this video again, rewatch it, it will be clear for you. So if everything is clear for you guys, Kundan, I don't get you, like what do you mean by why? If this is clear for you guys, then I'll move on to the next code, that is find the lexicographically smallest valid sequence. So if it is clear for you guys, you don't need to write clear, just write C. Okay, so that I'll move on to C. People new to this channel, I'll just request you, please do subscribe my channel and like the video. Yeah, clear. What rating can you give for this problem? Sachin, what I do is basically every day, I mean for every live I go, at the end of the contest I rate the codes. Okay, so I'll just rate it at the end of the contest. You can either wait and watch throughout the whole video, or if you're busy right now you can just go right now and like you can watch after I post this, I mean after this live video becomes posted. Okay, okay, so the watching is very nice right now. It's 12 right now, the watching is 12. Thank you guys, thank you so much for watching this, and 12 guys who are watching this, please do subscribe my channel. Okay, let's move on to this question, the third question. Find the lexicographically smallest valid sequence. You're given two strings, word1 and word2. A string x is almost equal to y. So is it like I think I did the code in Java, right? 12 watching and 4 likes not there. You can't do anything about that, man. Like, I can't force people, right? I can't force people. But yeah, I can request them that please do like it. Nothing more than that. So you're given two strings, word1 and word2. A string x is called almost equal to y if you can change at most one character in x to make it identical. A sequence of indices sequence is called valid if the indices are in ascending order. Concatenating the characters at this indices in word1 in the same order results in a string that is almost equal to word2. Okay, so what does it say? So let's say if I'm having VBC, let's say I'm having this only. Okay, I'm having this, or rather I'll take it from here. Okay, it will be better for me. Now notice one thing. If we are going to take this B, then this B, and then this C, so that is basically equal to ABC, apart from the fact that this element is not there. So basically you have to find out, like, at most one element can't be there, and taking that into consideration you have to find out the sequence that is lexicographically smallest. What does lexicographically smallest mean in this case? It means that you have to start it as soon as possible. Okay, because like it doesn't mean in this case, but the approach, the solution that I'm going to tell you, it basically demands that only, that you have to make it in that sense only. Okay, make it in that sense only. Okay, so how can you do this? Okay, how can you do this? Now there are various approaches. I will be explaining you various approaches. Okay, so first go with the first approach, okay, which I came across but I couldn't code it down, but that is the most easiest approach. Okay, that is, what would be the rating of today's last question? Is it above 1600 if compared to Codeforce's rating? I feel it is above 1600. That much I can surely say, because that was using like a lot of advanced algorithms. Okay, so if you don't know those algorithms, it will be difficult for you to understand. But the last question, I think it is, for me, it is easier than this question. Let's see this question. Okay. Hello, 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 hello. I can't spell your name though. Are you comfortable with English? But I can't help you out if you're not comfortable with English though. This is Del in Taiwan. Hi Del. Del fan. Okay. Now what you can do is you can just ignore the fact that I can both easier than three. Hi. Hi, nice to meet you. Yeah. Nice to meet you too. You just skipped, even I skipped third question. Okay. Even I skipped the third question. So now see, what you can do is you can just put this off and put this off. Okay. Because in any condition, you can replace this element with this element, right? But the moment you put this first elements off from both of them, now you have to find out B and C. That is, B is over here and C is over here. Okay, so you got a valid thing. Clear? So you got one thing, that is eliminating the first element. So you eliminated, ignore my handwriting though. So you eliminate the first element. Okay. Now let's say you have eliminated the first element. After that, it's normal traversing throughout throughout both the strings only. Okay. But what if you don't want to eliminate the first element? Okay. What if you don't want to eliminate the first element? In that case, I'll go over here. Okay. I'll do this. So in that case, you know that you have to find out the maximum suffix that you can have. Okay. You have to find out the maximum suffix that you can have. So is there a A? Yes, there is a A. So the A is over here. But is there any B and C over here? But there is no B and C over there, right? So based on this, the maximum suffix is A. Okay, the maximum suffix is a. Now if the maximum suffix is a, and then from that position there is no other element only, so in that case we can directly say that we have to eliminate the first element, otherwise there is no other step, right? So I think this example is not good for you to understand what I mean is what I basically mean. I'll go with this example. Okay, so now see, for this example, if you're eliminating the first element, now there is a thing. Okay, if you're eliminating the first element, there's two elements, so it is BC, right? It is BC, and there is no B over here only, so you can't do that, right? So now you have to find out the longest suffix. So what is the longest suffix over here? It is A only, right? It is A, because B is not there, right? Now since I know, this is the most important thing, that since I know that the last position that came into my consideration is A only, now I am going to delete the B and then search for C for the remaining part. And the moment I find it, I can say directly, and I, since I am deleting B, I have to delete this C also. Okay, I have to delete this C also, and then from the next part, I'm going to search for C. The moment I find C, I can say that this, and this is a valid thing. Is this clear? Is this clear with you guys? Because this is the most simplest explanation of this whole question. That is the first condition. You eliminate the first element and check throughout the whole thing. Otherwise, you eliminate the first position, that is like you do check the, I mean, what I'm telling you, you don't eliminate the first position, you check out the longest suffix and then cut off the positions which is not there, and for the remaining position you check it. Okay, using this approach you can easily come to a solution. Okay, using this approach you can easily come to a solution. Now I think the approach that I am thinking to explain, it is not in over here. Okay, now there is an exceptional case. So I am assuming that these two cases are like works. You get the basic idea about these two cases, right? If you get the basic idea about these two cases, just write in the live chat that three. Just write in the live chat three, so that I'll go to the third idea, that is the exceptional case. Just write in the live chat three. Okay, let's go to the third idea. What if it is like this? I have a V, I have a A, I have a B. Okay, or rather, let's say I have a V, I have a A, I have a A, and over here I have a A and I have a A. So in that case, the first condition, you remove this and check this AA, right? So that is done. But what if there was a B over here and the B over here was over here? Okay, so in that case also it is sorted. Okay, in that case also sorted. Actually, now I have to think about the exceptional case. I forgot like what the exceptional case was. I thought of. Okay, I think the exceptional case was that everything is there in this. Okay, that was the exceptional case that I was thinking of. But I don't think that will be needed. Okay, the exception case won't be needed actually. It won't be needed. So okay, no, there is no exceptional case. Okay, so there are only two steps. So this one, the first one, and the second one. So can you guys code it down? Can you guys code it down? Like if I tell you this logic, can you guys code it down? Just tell me. Tell me quickly if you guys can code it down or not. Because I haven't coded it actually. Okay, so that's the reason I'm telling you. Can you guys code it down? We can. Sure. Then I won't code it. Okay. Then I won't code it. Well, that is easy only, right? I was checking out. I found another thing. Okay. I did this. That is, I'm taking a longest suffix BP kind of thing and then doing it. Okay. I did it like that. I think this thing is more complex for you to understand. Rather, that will be easier. And one more thing I forgot to mention. What if in second idea, word one has A and B not next to each other? Word one has A and B not next to each other. Word one. Uh, Word one is the first word, right? How to get this idea during the contest? Okay, that is like uh, I don't know how to get it. It just clicks. Okay, it just clicks, and it's also about luck. Also, that sometimes you may not get the idea. It's okay. But let me. I mean, word one is equal to BACBC. Okay, so let's do BACBC. Whatever he is telling me, and this is ABC, right? This is what you mean. So if we remove these two words, so it's becoming BC, and this is BC. So in that case, you can do it by using this only, right? The answer will be 0, 3, 4. So you get it using the first case only, right? Isn't it true, Aditya? So is it clear? Aditya, is it clear? Is your like confusion okay? This was I was doing like if the first word is not like I have to check for both the cases, right? I have to check for this also and this also. But if in this case only it satisfies, so I don't have to like do anything, right? Because if this case satisfies, then this is lexicographically much smaller, right? And this is lexicographically a little bit more than this. Because over here you're not going to take the first element, right? But it may happen that this is lexicographically smaller also. When it will happen if the first element are same for both of them. In that case, this will be a better option, right? In that case, this will be a better option. But otherwise, I think the previous one is the better option. So basically, you have to compute for both of them and check that if for both of them it works, then you have to find the lexicographically minimum one. And if for any one of them it works, then you have to return the one for which it works. And if for none of them it works, so you can just return an empty array. I think it was empty array only, right? Yeah. So if there is no valid indices, you just return an empty array or an empty vector if you are doing it in C++. Okay. So let's move on to the last question, the question of the day. No, it's not the question of the day. People new to this channel who is watching this, please do subscribe my channel. Please do subscribe my channel and like this video, okay? So first, let's get into the video. I mean, let's get into the question. Anyways, guys, it was clear, right? Aditya told yes, it's clear. So I moved on to D, right? Can I move on to D? First tell me. If you think that I can move on to D, just write it in the live chat D, D, D. Okay. Anyways, Aditya, I'm going to play chess today also. Okay. I'm thinking of playing chess today also. You're given two strings S and pattern. A string X is called almost equal to Y if you can change at most one character in X to make it identical to Y. So that is almost similar to the previous question only. Okay. Return the smallest starting index of a substring in S that is almost equal to pattern. If no such index exists, return -1. Okay. So can anyone tell me that after seeing this kind of question, like obviously you can't have a big O n squared approach, okay? If since it is 3 into 10 to the power 5, you can't have a big O n squared approach. Follow up is, could you solve it if at most k consecutive characters can be changed? At most k consecutive characters can be changed. This is a very harder version. This is a more harder version, okay? Exactly. Exactly what I was talking about, okay? You have to use sliding window. But how can you use the sliding window? Think about it, okay? So if the sliding window was like this, key, you have something, okay, you have something, let's say you have to like match both the strings. So if you had to match both the strings, the sliding window would have been an easier approach, like a way easier approach. But now over here we have to modify the sliding window, right? Because let's say if I'm going to consider the first condition only, okay, we have to take two character in consideration at a time while sliding. Yeah, that's what sliding window is, okay. So if I just paste this thing over here, okay, so now the sliding window will look like A to 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, A to F, and then the sliding window shifts from here to one place apart from here, right? Now, do you think that the sliding window is as simple as you may approach it? The sliding window is not simple because if you're going to append and delete a character, right? If you're going to append a G and delete the A from the string, you will be needing big O of this length. Big O of, let's say this is M, you would be needing big O of M. You can do for each character match in S and string, increase the size of sliding window as sliding window holds. You can do like for each character match in S and string, increase the size of the sliding window. Sliding window fails if the incorrect match is more than 2. Exactly. Exactly. That is exactly what you have to do. Okay. Actually, he told the whole answer only. Now I'm thinking that whether I should explain it or not. Okay. So if you go like that, you can just have the like for these specific positions, you have to find out how many positions were satisfying and how many positions were not satisfying, and then you have to go for this also. Okay. Now what I did was, okay, what I did was why I was getting a TLE also is that I was hashing them. Okay, I was hashing them. So what is hashing basically? I'll explain you the hashing concept also. Then I'll go to the concept that I will be explaining. That is what Keaton told us. So basically, if you hash it, you know that this value can be from A to Z, right? Now, what do I mean by hashing? The hashing is like I'm going to give it I'm going to name a different number system based on that. Since it is from A to Z, so it can consist of 26 alphabets. Now we know that whenever you're going for decimal, the elements are from 0 to 9. That is 10 elements. So 10 is the base for decimal system. 2 is the base for binary system. Now we can introduce a new system called alphabet system and have it at the base of 26. So in that case, we can find the number in this case and this case and go on doing it. Okay. But if you do that, what will happen is the problem won't be that you will having a TLE. Okay. You will get a lot of test cases satisfying. But since the hashing becomes very huge, that is if you're having a base of 20, if you're having a base of 26, the hashing becomes so huge that it becomes completely impossible for you to mod it down. So that's the reason it doesn't satisfy. Now, how can you make it satisfiable? How the heck I was doing this? Okay, my Java code got rewritten as the C++ code. I don't know what the heck happened. The Java code contained what Keaton told us. Okay. Okay, we can do it again also. Okay, we can do it again also. In dp is equal to new int n. See, I'm taking an array dp and n is basically the length of the string s. Okay. And in this dp, what I do is I'm going to store. Okay, no, no, Keaton, you're wrong. Sorry, I'm so sorry. I'm so sorry. I'm so sorry, Keaton, you're wrong. So what I told you, that is only the answer. Okay. So why is Keaton wrong though? Can anyone tell me? Can anyone tell me why the logic that I'm going to check how many are same in this till this position and then check how many are same for the next position is wrong? Can someone tell me? Ten people are watching this right now. Okay, 10 people are watching this right now. So guys, be kind of responsive. Okay, just be kind of responsive. Okay, I thought it like that. Take two letter from what to and start looking for anyone. Or if the second letter is found, mismatch. While now see one thing. When you are checking for this, so it is A B B C C D D F E F and F G. But when you are checking for the next thing, now the matching will be with B B C C C D D E F F F G G. Right? The matching is only different. The matching is only different, Keaton. You get it? So that's the reason we can't do that. So basically, you have to escort to my system of hashing only. Now, how can we hash a string? So let's say you have A, B, C, right? So what is the corresponding value of this A, B, C? This is 1, this is 2, and this is 3. Now, how do we convert a number into its decimal form? Of any other, like of any other base, how can we convert it? We just multiply it with 26 to the power a specific value, right? Let's say I'm multiplying this with 26 to the power 0. And then I multiply this with 26 to the power 1. And this with 2. So you get the answer, right? Now it is very much evident that since we are just introducing a new number system, what does a number system contain? The number system is a number system for alphabets. Okay, the number system is a number system for only alphabets. So is this clear that we are introducing a number system for only alphabets? Because we were given that all the elements are from A to Z only. It was given in the question. Okay. It consists of only of lowercase English letters. So is this clear that we are just introducing a new number system? Is this part clear how we are introducing it? Write it in the live chat, okay, if this is clear. Anyways, people new to this channel, I'll just request you, please do subscribe my channel, okay, and like my video. It will be helpful for me. Now see one thing. Let's say I have an extra D over here, and when I am shifting the sliding window, so I will be removing this A and adding this D, right? Now what happens? This 26 to the power 1 becomes 26 to the power 0. This becomes 26 to the power 1. And this becomes 26 to the power 2. Right? Now if before adding it, before doing anything over here, what is the number of operations that you have to perform on over here so that this becomes this? You can simply divide the whole thing by 26. Okay. Similar to that thing only. Similar to how you convert from binary. Exactly. Similar to how you convert from binary to decimal. That thing only. Okay. So you can divide it by 26. After you get it, add 26 to the power the length of the sliding window minus 1. That is this 2 over there. So do you get how we are calculating for the sliding window? Is this part clear with you guys? The sliding window part. One more time. Okay, sure. Since you got this by 26 part, right? You got this by 26 part. So now what happens is this 26 squared is being added, right? I mean 26 squared into this, that is 4. Why is it 4? Because it is D, and D is the fourth element. Or rather it won't be 4. Okay, I made a mistake. Since it is 0 based indexing, so it won't be 4. This will be 0, this will be 1, this will be 2, and this will be 3. Okay, this will be 3. So basically you are going to multiply how to prepare for hard question appear in contest of LEETCODE and code courses. To learn advanced algorithm, please guide and suggest. Now see, I can give you a source where you can check out all the advanced algorithms out there that are there in the market. But what eventually will happen to you is you won't get to know like how to implement them and where to implement them. Okay, so I'll advise you that go through previous contests, okay, and try to solve them, try to absolve them. If you can't solve them, try to absolve them, try looking at the editorials and solve them. So what happens is you get accustomed to all the advanced algorithms one by one. Okay, so that's it, my suggestion for you. I did it like that only, so that's it. So this is 26 squared. So now I think this is clear, right, Aditya? Like this number system. This is basically normal basic number system. Just I am introducing a new number system, which is of the base 26. Nothing more than that. Okay, the base is 26 values. Now from the previous hash and the now recent hash, so for every sliding window, we can check if at most one number differs or not. Okay, how are we going to check that? So if 0 numbers differs, that means the value of both the values, okay, are going to be same, because if it is 0. But if it is not 0, then the difference will be a number into 26 to the power k. What is the k? Let's say the number at the third position differs. Okay, the number at not the third position, the number at second position differs. Okay, at this position the number differs. So what will be the difference between the hashed values? It will be the difference between this and the hash to, and the value that is there in the original array, you subtract them and multiply it by 26 to the power 1. Okay, now it may not be that clear for you. Okay, so I'll just implement a example test case. Okay, so let's say I have got ABC and over here I have got AAC, right? This is a valid thing, right? This is a valid thing. Now how can we say that it's valid? So these two numbers, they both get multiplied with 26 to the power 0. These two numbers, they both get multiplied by 26 to the power 2, and these both numbers get multiplied with 26 to the power 1. Now if we subtract these two numbers, so a into 26 to the power 0 and a into 26 to the power 1 gets cancelled out, and c into 26 squared and c into 26 gets cancelled out, because both of them are same, right? But over here these two are having a different value. So what will this be? It will be b minus a into 26 to the power 1, right? Is this clear? Is this clear with you guys? Guys, if there are 8 people watching it right now, so it's like my subscribers are still 1.83 thousand only, right? It's 1838. So can we make it 1.84k? Just two more subscribers. Can we make it? Make it 1.84k, okay? Make it 1.84k. So now from this case, what we can say is we have to find out the position where it differs. Okay, we have to find out the position where it differs. And it is easy for us to find it out, the position where it differs. How? Just the way you do binary subtractions, the same way you're going to do subtraction over here. Okay, after you've subtracted it, now no matter whatever this value is, okay, no matter whatever this value is, it will be always lesser than 26, right? So if I take this whole thing, because I don't know what this power is, okay, I don't know what this power is, but if I take, let me keep it over here only, but if I take this whole thing and check it by making it log 26 base of this, so whatever our answer is going to be, that is going to be this power, because this number is lesser than 26, so this is not going to contribute anything to the log, right? It is going to be in the decimal part. This part is going to be in the decimal part. Is it clear how to get this power? Is it clear? Clear. Now if you get the power, so you know what is the position where it differs. What is the position where it differs? It is a power only. The position where it differs is a power only. Okay, that is at the 1th position only, not the 0th, not the 2nd, the 1th position. So now you're going to check if you, the whatever this value is, whatever you got, now you're going to make b minus a, okay, b minus a into 26 to the power this value. If both these values are same, if both these values are same, that means it is a valid string. If it is not same, what does it mean? That even, like, not only in this case but in some other case also there was some problem. Okay, only if this is same, then only we can say that it's a valid case. Is this clear with you guys? Because that is the end of the whole thing. That is the end of the explanation. So only if it is clear, then only tell me, okay? 15 people are watching this. We are aiming for 2K subscribers, man. Just subscribe my channel, okay? Just subscribe my channel. Just subscribe my channel and like this video. People who are watching this. The last part repeat, okay? See, how did you get this? You can get this value by logging this whole thing. Now see, whatever is in the red now, this red. So let me give it a different color. Let's say give it green only, okay? So whatever is in this green part, this we don't know. We just know the value of this green part, but we don't know what is the value of the whole this b minus a and 26 to the power this, right? That is unknown to us. We just know the value of the whole part, and from the whole part's value we can deduce that the value of this, what this value of exponential can be. And after deducing that, we are going to put that value over here and check whether our deduction was right or not. Okay, we are just predicting something. I mean, we are just deducing something and then checking whether the prediction or the deduction is right or not. If it is right, then we can say that it's a valid case. Now, is it clear, Aditya? People who are new over here, it's a mild request. Please do subscribe my channel and like my video. Okay? कर दो यार, कर दो. इतना बोल रहे हो तो कर दो यार, कर सकते हो. Okay. So now, if you look at the code, I am using one hash called hash. Okay, I do this only power 26 this thing, and I am using a mod function because a mod will be needed. Okay, a mod will be needed because the values can be very large. So in that case, a mod will be needed. And then I'm doing the same thing for this also, and then I'm running a sliding window. Okay, then I'm running a sliding window from m to n, and I'm doing the same thing. Okay, now if you look at this thing, so I'm just having a d which is going to be the difference of hashes. But since you know one thing, that you can't log out a negative number, right? Sometimes you can't log out a negative number. So in that case, what you can do is, if it's a negative number, you can have a flag and check it out and make the number absolute and then compute the whole thing. And after that, based on that, you can multiply that with it. Okay, so if it's negative, then you can multiply it with -1, otherwise not. Okay, over here you may ask me that if it's d is lesser than 0, I made f equal to 1, and if it's not so, then I made f equal to -1. That is the opposite of what it should have been. It is because I was taking it in a different manner. Okay, I was taking it hh minus hash instead of taking it as hash minus hh. Okay, yeah, the code is kind of complex, so that's the reason I just explained you the logic. So I'm having a hash, I'm having a count, then I'm hashing it out. That is I'm finding the hash for the string pattern. Okay, then I'm hashing it for the string s, and then if both the hashes are same, we can say that the first position only satisfies. Otherwise, we have to check for the remaining part also. Okay, so what we do is, basically we are making it log of d base of 26. Okay, log of d base of 26. And one more thing, d should be divisible by 26 to the power log, that thing. Okay, why is it so? Because it may happen that after you perform this, there are some elements before this also, right? Some elements which are very negligible, let's say +1. So in that case also, this 1 won't be considered, but this 1 is going to come from 26 to the power 0, right? So in that case, we have to eliminate them also. So that's the reason I'm just eliminating them. Okay, and then I'm going for f into this. If it is equal to this, then return 0. Then I'm going for the sliding window and I'm checking the remaining of the sliding window. Will it be able to handle it power Yeah, exactly. That is what I was telling you, na. That if the power of 26 comma that is too large, then it can't handle it. So in that case, you need the like a perfect modulus operation, and that is the place where the Z algorithm comes. Z or Z algorithm. Okay. So you guys can like I can explain you the Z algorithm, but I think it will be better that I don't explain you guys the Z algorithm because I think the Z algorithm is kind of similar to what the KMP algorithm is. But anyways, I think it will be better that I don't explain you the Z algorithm because it's a quite advanced algorithm, and even till date I struggle to do that. Okay, so maybe while explaining, I have to look at the editorials of some other editorials. So I prefer that you get the basic knowledge about this thing, and then you can just implement it using some other. Can you look into my code? I think it could. See, I haven't looked into your code though, but yeah, I will look into it. Okay, after I finish the video. Now comes. So is everything okay for you guys? Is everything okay? Perfect for you guys? Okay. Now comes a part that what we are going to do is we are going to read the problems. Okay, we are going to read the problems. Right? Okay, so let's start with the reading of the problems. The first one was very easy. The first one was very easy. I'll rate the first one over here. So basically, what are this? This is easy. This is easy between easy and medium. This is medium, and this is hard, and this is impossible. Okay, and the things between them, they are the transition levels. Okay, so A was easy, B was a transition between easy and medium. Just let me check the B also first. No, I think B was not med. I think B will be medium only. Okay, because it was not that easy. B will be medium, and C was hard. C was undoubtedly hard, and D was impossible. So there is nothing between the transitions. Okay, because D was impossible because you can't do D without having a prior knowledge. But I think I haven't come out with other knowledge also. There may be some other algorithms because I haven't seen Keaton's code. So if I can optimize that, it may become easier. Can you tell in terms of rating? Okay, rating like code forces thing, right? We're talking about code forces. No, I won't tell it on terms of rating because if I'm talking about in terms of rating, it becomes like kind of biased. Okay, so I can just tell you that this easy is like a rating from 600 to 800. Okay, something like that. I can give you the range of the ratings. Medium is somewhat 800 to 1k. It's not 800 to 1k, it's 900 to 1k. Okay, hard is like hard. It is somewhat beyond 1.2k, and this is 1.5k. Okay, or maybe more also because I'm not that much accustomed to the rating system. So that is the rating system for now. Are you guys happy with the rating? And like, are you guys happy with the reading? Aditya, would you play chess? I'm up for just one round only. He deserves 2000. Yeah, I think, yeah. Right. You're right. He will be like somewhere over here. Okay. He deserves 2000. Even if not 2000, it was 1.9k. 1.8k for sure. It was 1.8k for sure. You happy with this contest? That's good. Aditya, should I send you a request? Yes, what time is it though? It's 11:01. So if I play chess, it will be not for more than 5 minutes. Okay, I'll just send you a request. So it will be a 5 minute thing, okay? I mean 5 minute, 10 minute thing. Yeah, I'll do the post contest discussion tomorrow also. Tomorrow morning, 8 a.m. Guys, be ready. Aditya, I think I have sent you the request. I think there is some glitch, so I'll just cancel it and send them again. Oh fuck, I don't want to play with some other. Okay, just play it with some other random. Okay. I know I'm gonna win. I'm gonna lose it because I have not been playing chess for a long time. Yeah, because I think there was some glitch and I accepted some other person's request. Okay. I'll just go for a draw, man. I don't want to play it anymore. Decline the draw. Okay, it's okay. Yeah, I know. I yeah, I can go for this. Okay. So what he'll do is he's going to basically attack me with the queen. I think he's going to put the queen over here in c3, I guess, or not so. Okay. No, I'll keep it over here because this needs to be over here. Oh, okay. Okay, what the heck is wrong with me, man? I can put it over here. Yeah. I'm low on time though. I think I'm gonna lose this. Should I take the? Yeah, I'll take it. If he accepts this, then I'm going to go for this. He won't accept this. Not a big issue from my side. Damn, nice. Holy. Uh, I don't know why I did this. I think that was a blunder. Yeah, it's not a big threat, I guess. Okay. Fuck. Damn, 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 damn. That was damn, man. That was a good game. That was a good game. I made a lot of blunders. Yeah, I know I made a lot of blunders. But yeah, exactly. I think I missed one. Anyways, leave it. I won't play much today. Okay. So that's it from my side, guys. So I'm going to end the video over here. Thank you guys for watching my video. Thank you. That's it from my side. Thank you. Radhe Radhe. Good night. And see you guys tomorrow for after the LEETCODE weekly contest. Okay. Radhe Radhe. Good night.